Fine. Now you all can give your attendance in the chat box. I repeat, you can give your attendance in the chat box. Let me present my screen first. Uh, Wait. Okay. Hmm. Can you respond whether my slide is visible or not?
Yes, sir.
Okay. So in the last class, we have started solving problems on fatigue failure. And if I recall, we have solved the first problem. Krishanu, you were there. Can you tell me whether we have solved the first problem or not?
No, sir, I didn't.
Oh, okay, fine. What I recall is that in the last class, very few students were there. Four of them were there. So, okay. Once again, I am repeating this first problem. Fine. Okay. So this problem was asked in the year 2018. What the problem tells you is a bar is subjected to a combination of a steady load of 60 kilonewton and a load fluctuating between minus 10 kilonewton and 90 kilonewton. The corrected endurance limit of the bar is 150 megapascal. Yield strength of the material is 480 megapascal and ultimate strength of the material is 600 megapascal. The bar cross section is square with side A. If factor of safety is 2, the value of A, that is the side of square, in mm according to the modified Goodman criteria is dash. That is what you need to find out. So, can you tell me what all things are given in this problem and how we can proceed this problem? What all things are given in the problem?
Sir, F max and F min are there.
In the problem, it has been told to you that a bar is subjected to a combination of steady load of 60 kilonewton and a load fluctuating between minus 10 kilonewton and 90 kilonewton. That means, say if this is my body or bar, on this bar a steady load is acting which is not changing with time, that is 60 kilonewton, as well as on that same bar fluctuating load is also acting which is fluctuating from minus 10 to 90 kilonewton. Then I can say that the overall, then I can say that the I can say that the overall fluctuating load acting on this body will be 60 minus 10, that is 50 kilonewton one side, another side will be 60 plus 90, that is 150 kilonewton. So overall on this bar a fluctuating load is acting which is varying from 50 kilonewton to 150 kilonewton. Is the step clear?
Yes, sir.
That means F minimum is 50 kilonewton and F maximum is 150 kilonewton. Fine. Corrected endurance limit of the bar is 150 megapascal. What is this value? What is this value given? Corrected endurance limit of the bar means which value is given to me? Can you tell me the corrected endurance limit of the bar is which value? Hello. Hello. Can you hear me?
Yes, sir. Yes, sir.
So can you tell me this fluctuating corrected endurance limit of the bar is which value? This corrected endurance limit of the bar is nothing but SE. SE is given to you. That is corrected endurance limit. SE is given to you. And the yield strength of the bar is 480 megapascal. That means SYT is given to you. And ultimate strength of the material is 600 megapascal. That means SUT is given to you. So if I have the value of F min and the value of F max, I can calculate the alternating force acting on this component. That will be half F max minus F min. Fine. So half of 150 minus 50, that is 50 kilonewton. This is the alternating force acting on the component. Is it clear? Hello.
Yes, sir.
Yes, sir.
Fine. Similarly, I can calculate the mean load. I can calculate the mean load acting in the component. That mean load will be half times of F max plus F mean. F max is 150 and F mean is 50. So it is 100 kilonewton. Mean load is 100 kilonewton and alternating load is 50 kilonewton. Combination of mean and alternating is creating fatigue in this problem. So if we have calculated the value of alternating load and mean load, we can calculate the value of alternating stress and mean stress. Mean stress sigma m is what? Mean load divided by cross sectional area of the square, and area of the square is nothing but side square.
Okay, sir. Hello.
This is
Hello.
your sigma m. Alternating stress sigma A is what? That is alternating force by cross sectional area of the square. Again, that is side square. So FA by A square. FA again I know that is 50 kilonewton. So 50 into 10 to the power 3 divided by A square megapascal. Is it clear? Sigma M and sigma A.
Yes,
Yes,
sir.
sir, clear.
Clear.
Fine. Now how I get the now what you need to find out, you need to find out the side of the square by taking in criteria modified Goodman diagram. So if you know the modified Goodman diagram, it is obtained by combining the normal Goodman diagram. What is your normal Goodman diagram? Normal Goodman diagram is a line that will join SUT on x-axis with SE on y-axis. This is your normal Goodman line. So this SE to the point A to F, this is your normal Goodman line. Fine. You have to combine this line with the yield line. Yield line means the line which is joining yield strength in x-axis to the yield strength in y-axis. That means this dash 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 line. If you combine these two lines, the resultant area is your OABC. This is the and this is your modified Goodman diagram. That means you firstly what we will do, we will write down the equations of Goodman line. With that we will find out what is the value of this square A, and then we will use the equation of yield line. I will find out what is the value of the side of the square A, and then we will see that which value is maximum, because we are designing for maximum stress. The side of square which is maximum, fine, that will be my required answer. So I know that the equation of Goodman line is what? Sigma A by SE plus sigma M by SUT equal to 1 by factor of safety. Sigma A is this value plus sigma M is this particular value, 100 into 10 to the power 3 by A square is equal to 1 by factor of safety. Factor of safety is given in the problem, that is 2. AC is given in the problem 150. SUT is given in the problem 600. Sigma A and sigma M already we have calculated. If we solve this equation, we will get the side of the square A to be 31.62 mm. Is it clear?
Yes, sir.
बाकी लोगों को कोई डाउट किसी को इसमें?
No, sir. No, sir.
Okay, now next, since we have to use the modified Goodman criteria, which is the combination of Goodman criteria and the yield line. Next, again will find it out the side of the square A by yield line, and that yield line equation is sigma m, that is x-axis. In x-axis is your sigma m divided by intercept on x-axis. If you check this diagram, which diagram? This particular diagram, x-axis is sigma m, y-axis is sigma a, and equation of straight line, I know that x by a plus y by b equal to 1, where a and b are the intercepts on x and y-axis. So for x-axis, this line is joining at SYT. So this will be the value of A, x-intercept, and for along y-axis, this line is joining at point D. So value of B, that is y-intercept, is SYT. So sigma m by SYT plus sigma A by SYT. That is the equation of yield line. That is the equation of yield line. Sigma m by SYT plus sigma a by SYT equal to 1 by factor of safety. Again, sigma YT is given in the problem, that is 480 megapascal. Sigma m and sigma a already we have calculated. FOS is given in the problem. Just substitute all these values and get the value of A. So your side of the square A is 24.99 mm. Out of these two value, this particular value is maximum. So we will design this problem for this maximum side of the square A. So my answer, that is the correct side of the square, is 31.62 mm. So this is the final answer. Is it clear?
Yes, sir. Yes.
Fine. Okay. So this was asked in 2018. 2018 में पूछा गया था ये क्वेश्चन. इजी क्वेश्चन है. बस यहाँ पे आप कहाँ पे फंसोगे? इस क्वेश्चन में आप यहाँ पे फंस थे, क्योंकि एक तो क्वेश्चन में बोल रहा है कि स्टेडी लोड भी एक्ट हो रहा है, एज वेल एज फ्लक्चुएटिंग लोड इज आल्सो एक्टिंग. सो हाउ टू प्रोसीड हियर? You can get confused. And second, where you can get confused, that you have to use the equation of Goodman line also, as well as the equation of yield line also, and then the best of the two value you have to take. This is the second point of confusion in this question which can arise. Fine. So any doubt?
No, sir.
No, sir.
No, sir.
Okay. I can see that four people have joined, but only two people have given their attendance. That is Ria and Krishanu. Other people, please write your attendance in the chat box. Okay. So let us solve the second problem. This problem was asked in the year 2018. The problem is fatigue life of a material for a fully reversed loading condition is estimated from the equation sigma A equal to 1100 into n to the power minus 0.15, where sigma A is the stress amplitude in megapascal and n is the failure life in cycles. Maximum allowable stress in megapascal for a life of 10 to the power 5 cycles under the same loading condition is dash. So what is given in the problem and how we will solve this problem? बताओ क्या दिया है क्वेश्चन में और कैसे सॉल्व करेंगे? थोड़ा सोचो, ट्राई करो.
Yes, sir. To दिया
Hello. Your voice is not clear. Your voice is not clear. Anybody else? Kishanu, Ria, Shaikat, how we will proceed for the problem? Okay, let us solve. See what is given in the problem, that a fatigue life of a material for a fully reversed, that means value of alternating stress is given to you, and it is nothing but a function of fatigue life, that is sigma A is equal to 1100 into n to the power minus 0.15, where n is the failure life in cycles. The maximum allowable stress amplitude in megapascal. That means you need to find out the value of sigma A maximum. Sigma A maximum for a life of 10 to the power 5 cycles. That means n is given to you. This n is nothing but 10 to the power 5 cycles. You need to find out the value of sigma A maximum. How you can find it out? We know that this amplitude stress sigma A is what? That is nothing but half times of sigma max minus sigma mean. So sigma max minus sigma mean by 2 is nothing but 1100 into n to the power minus 1.5. Is it clear? Is it clear? I am just writing
Yes,
the
Yes, sir. Yes, sir.
equation of amplitude stress. That is how much? That is sigma max minus mean by 2, which is nothing but equal to this expression that is given in the problem. 1100 n to the power minus 0.15. Is there any doubt?
No, sir.
Okay. Now,
No, sir.
if you see the first line of the problem, the first line of the problem will tell you is fatigue life of a material for a fully reversed loading condition. See, now from this expression, you have to find out the value of sigma max. That means you have to write sigma mean somehow in terms of sigma max. Then only you can substitute n as a 10 to the power 5 cycles and you can get the value of sigma max. So how you will substitute sigma mean in terms of sigma max? For that, you read the first line of the problem. That is fatigue life of a material for a fully reversed loading condition. Now, what is this fully reversed loading condition? What do you mean by this word called fully reversed loading condition? What will happen during this condition? Hello? Hello? Can you tell me what will happen in this fully reversed condition? If you remember the previous lectures, I have told you what is fully reversed condition. See this diagram. This is my reversed stress. In reversed stress, which value is 0? Sigma m is 0. And I know that sigma m is what? Sigma m is your half times of sigma max plus sigma min. If sigma m is 0, sigma max plus sigma min will be equal to 0. That means sigma max is equal to minus times of sigma min. And if you see the diagram, see, this is sigma max and this is sigma min. That means sigma max is equal in magnitude to sigma min but in opposite direction. This is the meaning of reversed loading condition. Is it clear? That means in this problem, which problem? That is in this particular problem, value of sigma mean will be minus times of sigma max. Why? Because it is the stress is fully reversed. Is the step clear?
Yes, sir. Yes,
Clear,
sir.
sir. Clear.
Fine. So in place of sigma mean, I can write minus sigma max. So sigma A is sigma max minus sigma max by 2, which is equal to 1100 into n to the power minus 0.15. Now this minus minus will become plus. Sigma max plus sigma max is 2 sigma max by 2. 2 cancel. So ultimately sigma max is 1100 into 10 to the power minus 0.15. So now just substitute the value of n. N is 10 to the power 5 cycles into to the power minus 1.15. Just solve it. You will get the value of sigma max as 195.61 megapascal. So this is the answer of this problem. Is the question clear?
हाँ सर हाँ
हाँ
Fine.
सर क्लियर है.
See, in this
बहुत
question,
इजी है सर
yes,
इजी
but
है
you have to click. No, आपको क्लिक करना पड़ेगा. आपके दिमाग में क्लिक नहीं कर रहा है तो करने. देखो गेट में टफ सवाल नहीं आता है. इन गेट में इजी सवाल आता है, बट आपको कॉन्सेप्ट पकड़ना है. If you see in this question, what was the concept is this fully reversed loading condition. For fully reversed loading condition, I know that sigma max is minus times of sigma mean. बाकी तो कुछ भी नहीं है इस सवाल में. बाकी you know that sigma a is equal to 110 times of n to the power minus 0.15, where sigma a is sigma max minus sigma mean by 2. So due to this fully reversed condition, sigma minimum will be minus times of sigma max. Just substitute in this particular expression. N is given to you. You can get the value of sigma max, that is a maximum allowable stress. That is what you need to find it out. कुछ है इस क्वेश्चन में? कुछ नहीं है. बस यहाँ पे कहाँ पे फंसोगे आप? बस ये फुल्ली रिवर्स लोडिंग कंडीशन, ये लाइन में आप फंस जाओगे कि इससे होगा क्या.
हाँ यही मेन पॉइंट है इस.
This is the main point of this problem. Is it clear? कोई डाउट? हेलो.
हाँ सर क्लियर है, ये वाला क्लियर है.
Okay, fine.
हाँ सर क्लियर है.
Fine, okay. Next is the third problem. Now, I hope you will solve this third problem. Please try to solve this third problem, then I will solve. Fine. Now, this third problem is what? A machine element has an ultimate strength of 600 Newton per millimeter square and endurance limit, that is sigma En, of 250 Newton per millimeter square. The fatigue curve for the element on a log plot is shown below. This is the diagram, that is SN diagram for this question is shown to you. If the element is to be designed for a finite life of 10,000 cycles, the maximum amplitude of completely reversed operating stress in Newton per millimeter square is how much? So please read this problem and tell me what you understood from this problem and how we can proceed. इसको पढ़ो. डायग्राम दिया हुआ है, ऐसे डायग्राम आपका, और मुझे बताओ कि क्या बोला गया है इस क्वेश्चन में एंड हाउ आई विल डू इट. I'm giving you 2 minutes time. Please think and then let me know how we can proceed for this problem.
सर इसमें अल्टीमेट टेंसाइल स्ट्रेंथ दिया हुआ है.
तो क्या दिया हुआ है?
हेलो. अल्टीमेट टेंसाइल स्ट्रेंथ दिया हुआ है सर.
Ultimate
हेलो.
tensile strength दिया हुआ है. Okay, and if you see the diagram, if you see this SN diagram, point A, value of point A is 0.8 times of sigma u. So sigma u is given to you. You multiply sigma u with 0.8, then you will get this coordinate point A. Fine. What else?
Endurance limit is also given.
Endurance limit दिया है. That means from the graph it is very much clear that the point from where the graph becomes exactly parallel to x-axis, from that particular point along y-axis is your endurance limit. So from this graph, from point B, the graph is parallel to horizontal axis. So if you extend this point backward on this y-axis line, this will be your sigma En. Fine. You will get this particular coordinate point. Okay. Then solve कैसे करूंगा?
N value is given.
N value is given, that is 10 to the power 4 cycles. Fine. तो निकालना क्या है? n दिया है तो
एम्पलीट्यूड स्ट्रेस निकालना होगा.
एम्पलीट्यूड स्ट्रेस किसके करस्पॉन्डिंग निकालना होगा? एम्पलीट्यूड स्ट्रेस किसके करस्पॉन्डिंग निकालना होगा?
सर रिवर्स ऑपरेटिंग।
नहीं, तो वो जो एम्पलीट्यूड स्ट्रेस है वो किसी पर्टिकुलर साइकिल के करस्पॉन्डिंग निकालना है। देखो क्वेश्चन में बोला गया है किस पर्टिकुलर साइकिल के करस्पॉन्डिंग निकालना है। That particular amplitude stress we have to find it out corresponding to a particular cycle. कौन से साइकिल पे निकालने बोला है?
फाइनाइट
लाइफ साइकिल।
साइकिल का what is the value of that particular cycle? In the question it has been told to you that
10,000 cycles.
for 10,000 cycle what will be the value of amplitude stress? That means
10,000 साइकिल
हाँ बोलो, कुछ बोल रहे हो? You want to say something?
10,000 साइकिल के लिए निकालना होगा, समझे आप?
Yes. So that means let us redraw this diagram. Let us redraw this diagram. So wait. Hmm. Can you see my white screen?
हाँ सर, दिखाई दे रहा है।
Okay. So let us draw that SN diagram first. So this is your y-axis, and y-axis is nothing but log. And the if you remember, this SN diagram is plotted in log paper, log base 10 paper, log base 10 SF. This is y-axis, and this x-axis is log base 10 n number of cycles, and the graph is somewhat like this. This particular value will be 6 because log base, this is what? This particular value is 10 to the power 6.
Yes, sir. Yes, sir.
That means this particular value is 10 to the power 6. That means log base 10 of n. Log base 10 of 10 to the power 6 is nothing but 6. This is given to me and corresponding to this horizontal line. Which horizontal line? That is this horizontal line. This particular value is your sigma En. Sigma En. Let us denote this point by point C. And this particular value from the question is say point A. And the coordinate and value of this particular point is what? 0.8 times of sigma u given in the problem. That is 0.8 times of sigma u given in the problem. And if this is 10 to the power 6, then this particular value, that is this particular value will be 10 to the power 3, and this particular value is 10 to the power 4. What I need to find out? I need to find out corresponding, and say this is B. Say this is B. We need to find out that corresponding to this 10 to the power 4 cycle. Corresponding to this 10 to the power 4 cycle, if I go up, what will be the value of this amplitude stress or this alternating stress. Is it clear? Is it clear?
Yes, sir. Yes, sir.
That means
हाँ सर क्लियर है.
if this is A, let us assume that this is point E. Let us assume that this is point D. That means ultimate, and let us assume that this is point O. So ultimately, I need to find out what? I need to find out the value of DO. That will be the alternating stress which we need to find it out. How to find it out? For that, let us find out the coordinates of all the points lying along y-axis. So first, let us find out the coordinate point OA. That means this O to A. This is how much? OA will be log base 10, 0.8 times of sigma u. Yes or no? Log base 10, then 0.8 times of sigma u. होगा कि नहीं होगा?
हाँ सर.
Fine, because both y and x axis is plotted along log paper, and this value of OA, that is log base 10.8 times of sigma u, is coming out to be, that is 2.6812. Similarly, I can find out this OC. O2C is what? O2C is log base 10n log base 10 into sigma e sigma en, because this particular point is endurance limit point. This will be the value of OC. Is it clear? Hello.
Sir, last part audit करिए.
Last part, I need see, this point C is given to me. Point C is what? Point C is sigma En. But I know that I draw this graph on log paper. That means x-axis is log base 10, y-axis is log base 10. So this value OC will be how much? This value OC will be log base 10 times of sigma En, that is endurance strength.
Yes sir.
बाकी लोग क्लियर है?
हाँ सर. हाँ सर.
Fine. So with
यार
this,
सर.
I will get the value of OCC. With this, we have got the value of OC. Now, what I need to find out the value of DO. For that, what I will do? Let us consider the triangle ADE and triangle ACB. Two similar triangles ADE. That means this particular triangle. This is ACB. This triangle and triangle ADE. I can write what I can write AD by AC. That is AD by AC. This much is AD and this much is AC equal to DE by CB. Can I write AD by AC equal to DE by CB? Hello.
हाँ सर. हाँ सर.
लिख सकता हूँ ना AD
सिमिलर
by
ट्रायंगल
AC
के
equal
साथ.
to DE by CB. So see AD by AC equal to CE by CB. Then AD by AC. How I can write AC? How I can write AC? Let us see. Now this A to C will be A2O minus CO. AO minus CO होगा. AC will be AO minus CO.
हाँ सर.
होगा ना. So AO minus CO equal to CE. That means this is CE. So your C is, wait. Yes. This C2E. This is CE. This CE is nothing but this DE. So I can write DE divided by CB. Can I write? AD by AC is equal to DE by CB.
Yes sir.
Fine. देखो. DE by CB. So this D2E. That means this DE value is how much? That value is your 6 minus 3. होगा ना. CB का वैल्यू. CB will be 6 minus 3. The C2B, this value will be log base 10 n, which is nothing but 10 to the power 6 minus log base 10 n, which is nothing but 10 to the power 3. So log base 10 to the power 6 is 6, and log base 10 to the power 3 is 3. So 6 minus 3 is 3. So this particular value CB is 6 minus 3. Clear? And this value, which is this value, that is the DE value, this value will be, see, this particular point is log base 10 to the power 4 minus log base 10 to the power 3. So it is 4 minus 3. So it is see 4 minus 3. So I can write AD divided by AC. AC is what? AC is AO minus CO. AO already we have, that is 2.68. 2 minus CO 2.3979 equal to 4 minus 3 is 1, 6 minus 3 is 3. With this, if you solve, you will get the value of AD to be 0.0944. Is it clear?
हाँ सर.
0.0944. Fine. So I got the value of AD. See the diagram? I got this value of AD. I need the value of OD. So I can write AO. AO is equal to AC plus AO is equal to AD plus DO. That is AD. That is this. AO is equal to AD plus D2O. I can write. Yes or no? I
हाँ
can
सर.
write DO as AD plus DO. Fine. Then I need to get the value of DO. So DO will be how much? This DO will be your
AO minus
AO
AD.
minus CO. AO minus CO.
हाँ.
AO already you have calculated, that is 2.6812. CO already you have calculated 2.3979, which is equal to 1 by 3. So AD will be, AD means, that is what I need to find out, that is this AD. इससे अगर AD आ जाएगा तो then we can write, then we can write that AO is equal to AD plus DO. So AD will be 1 by 3 into this particular term, which is coming out to be 0.0994. Since I got the value of AD, now I can write AO as AD plus DO, or DO as AO minus AD. Is it clear?
हाँ सर.
Fine. So AO already we have calculated minus AD just now we have calculated. So I got the value of DO as 2.5868. That means this particular value. That means this particular value of DO as 6.5828. So I can write it as AO is equal to AD plus DO. I can write AO as AD plus DO. So I can write DO as AO minus AD. AO already I have. AO already I have. That is this one minus AD. AD just now we have calculated 0.0994. Just subtract it. You will get the value of DO. You will get the value of DO. Since again all these values are kept on log scale, so log base 10 of SF, that is log base 10 of this DO 2.5868 will be how much? Will be 386.18 Newton per millimeter square, and this is the answer for this particular third problem. क्या कोई डाउट है किसी को कुछ?
नहीं सर।
इजी है कि टफ है प्रॉब्लम?
तो ये सब तो हमने किया है।
हाँ ये सब आपने किया है, वही चीज ये आया भी हुआ है, देखो 2017 में आया हुआ है. बट इन दिस क्वेश्चन वेयर यू कैन मेक मिस्टेक, यू कैन मेक मिस्टेक
सर
इन.
आपने करा है क्लास में ये सब?
यस यू
सिमिलर
कैन.
ट्रायंगल के वहां पे
Yes,
मिस्टेक हो
you can
सकता है।
make this mistake over this similar triangle. This is the main heart of this problem. बाकी चीज तो इजी है, बट यहाँ पे अगर गड़बड़ हो गया देन आगे पूरा प्रोसेस गड़बड़ हो जाएगा. और ये आया हुआ है 2017 में, डायरेक्ट क्वेश्चन है, कहीं भी कोई चेंज नहीं है. बट ड्यूरिंग दैट सिमिलर ट्रायंगल कॉन्सेप्ट यू हैव टू कीप इन माइंड व्हाट यू आर टेकिंग, whether you are taking the right thing or you are taking the wrong thing. ठीक है? Any
हाँ सर.
doubt? Any doubt?
नो सर क्लियर.
नो सर, नो सर।
Okay, so I don't think enough time is there. It's already 3:58 p.m. With this, I have or we have completed this portion, that is fatigue portion. Fatigue portion we have completed. Stress concentration, that portion we have completed. Theory of failure, that also we have completed. Fine. Then in the next class we will start this rivet joint. Fine. See, why I have selected all these topics from the fifth semester is that you have given the exam of design recently, design 2. So you know all those things. That is your what I say, rolling contact bearings, ball bearings, gears, flywheel. All these things you have studied recently. So you know all those things. But all these things which you have
सर
studied.
ये तो अभी
यस यस, हाँ वो आप लोग अभी पढ़े हो इसलिए आपको याद है, आप कर लोगे. और ये सब चीज क्या है, एक डेढ़ से साल हो चुका है, एक साल हो चुका है, ठीक है. तो अभी आपको वो याद नहीं है, इसीलिए मैं वही सब चीजों को अभी रिवाइज करा के वहां से गेट क्वेश्चन करा रहा हूँ. ठीक है?
हाँ सर।
ओके, सो इन द नेक्स्ट क्लास वी विल बी स्टार्टिंग
सर सोम का भी करने से अच्छा होगा सर. सोम का भी अगर प्रॉब्लम एक दो हो तो सर स्टिक टू द मटेरियल.
स्ट्रेंथ ऑफ मटेरियल आई थिंक मेरे पास मुझे तो मिला नहीं, शायद सुदीप तो सर को मिला है शायद. अब वो पता नहीं, ठीक है देखते हैं, टाइम मिलेगा तो करेंगे. पहले फिलहाल तो हम लोग डिजाइन खत्म करते हैं. एंड माय मेन टारगेट विल बी टू कंप्लीट दिस पार्ट, दिस फिफ्थ सेमेस्टर डिजाइन पार्ट, बिकॉज दिस यू हैव फॉरगॉटन. रिमेनिंग सिक्स सेमेस्टर पार्ट ऑलरेडी यू हैव डिड. फाइन. इफ आई वोंट कवर ऑल्सो, आपको पता है आप कर लोगे, लेकिन जो फिफ्थ सेमेस्टर का पार्ट है आपको, आप भूल चुके हो, आपने किया नहीं है. तो दैट आई हैव टू रिकैप ईच एंड एवरी टॉपिक एंड देन वी विल सॉल्व 3 to 4 प्रॉब्लम्स बेस्ड ऑन ईच एंड एवरी टॉपिक. फाइन. सो विथ दिस फ्रॉम द नेक्स्ट क्लास ऑनवर्ड्स वी विल स्टार्ट दिस डिजाइन प्रोसीजर ऑफ रिवेटेड जॉइंट. ठीक है?
हाँ सर।
Okay, then with this I end the this class over here. If you are having any